So in this video, I'm going to be going over the 2025 National 5 multiple choice paper, and these are unofficial solutions, so if you see any mistakes, then please let me know, and if you have any questions, let me know in the comments. And lastly, remember to subscribe and like the video and share with your friends. Other than that, good luck. So question 1 says, which row in the table shows both quantities classified correctly? So let's go through each option and rule each option out. So for A, we have weight as a scalar, and we can rule that out since weight is a vector. B, distance for a scalar, which is correct. Velocity for vector, and that's correct. So we can put a tick next to that one. Let's go through all the options still. Mass as a scalar, that's correct. Distance as a vector, that's incorrect. Force scalar, incorrect. Velocity scalar, incorrect. So the answer is B. Question 2 says, the graph shows how the velocity v of an object varies with time t, and we are asked to get the displacement of the object at 2 seconds. So the way to do this is to get the area under the graph, and that would be this area here plus this area here. So we use the area for a triangle, since these are two triangles, so a half BH plus a half BH, and now you substitute the values. So here, for the first one, I've used 6 as the height and 1.5 for the breadth. And for the second one, I've used 0.5 since we do 2 minus 1.5 for the breadth, and then minus 2 for the height. And that gives us 4 meters for the displacement. And that gives us answer A. Question 3 says, a car is traveling along a straight level road. The car slows down at a constant rate of 2 meters per second to the minus 2 for a time of 8 seconds. The final speed of the car is 5 meters per second. The initial speed of the car is. So my advice is whenever you're dealing with a lot of data, it's good to list your data. So U is the thing we're looking for. A is minus 2.2 meters per second to the minus 2 because it slows down at a constant rate of 2 meters per second squared. So that means we have a negative acceleration. So next we have V, which is 5 meters per second. And finally we have T, which is 8 seconds. So we use the formula A equals V minus U over T. We sub in the values, so minus 2 is equal to 5 minus u all over 8. And now we just rearrange for u. So minus 2 times 8 is minus 16 equals 5 minus u. So minus u is equal to minus 16 minus 5, which is minus 21. So u, we just take the negative of that, and that's 21 meters per second. So the answer is D. Question 4 says a cup rests on a table that rests on Earth. The cup exerts a downward force on the table. Which of the following is a reaction to this force? So, whenever you have this kind of question, the formula is if A exerts a force on B, then B exerts a force on A. So, we have the cup exerts a downward force on the table, so the table must exert a force on the cup. So, the reaction to this force is the force of the table on the cup, which is A. Question 5 says a crate of mass 180 kg is lifted through a height of 3 meters in 2.5 seconds. The minimum work done in lifting the crate through this height is. So immediately through this question, I can see that we need the work done. So let's write the formula EW equals FD. Now, in this formula, we actually need a force, but we're not given any force here. But if you think about it, you technically are given the weight. If you do W equals mg, I do 180 times 9.8, and that gives you a weight of 1,764 newtons. Now you can use this weight as the force, and then do 1,764, and it's pulled through a height of 3 meters times 3. So EW is 5,292 joules, and this rounds up to E, 5,300 joules. Question 6 says an asteroid of mass 25 kg is traveling at a speed of 9,200 meters per second. On entering Earth's atmosphere, the asteroid burns up completely. The maximum amount of energy released is. So, using the law of conservation of energy, we can know that the kinetic energy will be released as heat energy when it burns up. And technically, that's the only thing you can really do in this question. So let's do EK equals a half mv squared, which is equal to a half times the mass, which is 25 kg, times 9,200. Remember to square it. So EK is equal to 1, well, I think I round up to 1.06 times 10 to the 9 joules, and that gives me answer D. It rounds up to 1.1 times 10 to the 9 joules. Question 7 says the speed v of a satellite in orbit around the Earth is given by the relationship v equals the square root of r times g. And then you have a bunch of information here. So let's see what we're asked for. We're asked for the speed of the satellite. So let's use the formula v equals the square root of r times g. And then we do the square root of r, and r is the total distance from the center of the Earth to the satellite in meters. So basically, we need to do the radius of the Earth, which is the center, plus the height of the satellite, which is orbiting above. So we do 6.4 times 10 to the 6 plus 3.6 times 10 to the 7 in brackets, and then we can do times the gravitational field strength at the location, which is 0.22, and V works out to be 3,054 meters per second, and that rounds up to answer C, 3,100 meters per second. Question 7 says the weight of an astronaut on Earth is 710 newtons, and we're asked for the weight of the astronaut on Mars. So let's do W equals mg. We're given the weight, which is 710. We're not given the mass, and we know the gravitational field strength on Earth is 9.8. So we rearrange for mass, which is 710 over 9.8. So the mass works out to be 72.4 kg. Now we have the mass, we can do W equals mg again, where mass is a 72.4 kg, and on Mars, the gravitational field strength is 3.7 newtons per kilogram. So W works out to be 268 newtons, and that gives us answer C, 270 newtons. Question 9 says Sirius is the brightest star in the night sky. The distance from Earth to Sirius is 8.6 light years. This distance is equivalent to. So we need to get the distance from Earth to Sirius, but it's in light years. So let's do the formula D equals VT, where V is the speed of light, so 3 times 10 to the 8 times the time. So that would just be 60 seconds times 60 minutes times 24 hours times 365 days times the amount of years. So 8.6. So D works out to be 8.14 times 10 to the 16 meters. And that rounds up to E, 8.1 times 10 to the 16 meters. Question 10 says the line spectrum from a star is shown, along with the line spectra of the elements hydrogen, helium, carbon, and nitrogen. The elements present in the star are. So here it's just a case of probably using your ruler in the exam and matching up the lines with the elements. So let's see here. Let's do hydrogen. So there's a line here and there's a line here, but they don't match up. This bold line here does not match up, so it's not hydrogen. We can put a cross next to that. Helium, we have this line matching here, this line matching here, this one, this one, this one, and this one. So helium's in the star, so we can tick that. Next we have carbon, so we have this line matching here, this line here, this line here, this line, this line, and this line. So carbon's in the star, so we can put tick. And then the last one, nitrogen, and immediately we can see that this line does not match up. And let's just check, none of these lines match up over here. And that means nitrogen's not in the star. So the only answer can be helium and carbon. So the answer is C. Question 11 says a technician uses an oscilloscope to test three different power supplies. The diagrams represent the traces seen on the screen of the oscilloscope. and we have to identify the row in the table which identifies trace X, Y, and Z. So here we should know that we have two types of current flow, direct current and alternating current. Direct flow current is when the electrons flow in one direction, and alternating current is when the electrons continuously change direction to and fro. So in trace X, the line does not move between these two sides, so it does not go up and down like this pattern over here. So it means it only moves in one direction. So we can say trace X is DC, trace Y is the exact same, just up here. So this is also DC. And you can see here, this goes from positive to negative, positive to negative. So this must be AC. So the only answer here that works is E. Question 12 says an electric field exists around 2-point charges Q and R. The diagram shows a path taken by a charged particle as it travels through the field. The motion of the particle is as shown. So we need to identify which row in the table identifies the charge on the particle, the charge on Q, and charge on R. So let's assume that this particle is called P, just for easiness. So let's assume P and Q are like charges, and if they're like charges, then they must repel each other. So if the particle is moving, and this is the same charge, the path would probably look something like this. So we can assume that P and Q are not the same charge. They're opposite charges because they repel each other. So P is not equal to Q. And now let's assume that P and R are the same charge and like charges repel each other. So if P and R are the same, then the path will probably look something like this. That means P and R are opposite charges. Since the path move looks like this, it's being attracted to R. So P is not equal to R. So now we can look at the table and identify our answer. So the correct answer here is going to be A, since we have positive charge and two opposite charges here. Question 13 says a circuit is set up as shown. The reading on the voltmeter is 3 volts, so let's mark that in. And we need to get the resistance of resistor R. So there are multiple ways to do this, but the way I'm going to do it is use V1 over Vt is equal to R1 over RT. Now I'm actually going to rewrite this again just to use subscripts to make it a little bit easier for me. So I'm going to call this VR over V2, sorry, and R over R2. I'm going to move up here. So VR, if this is 3 volts and this is 12 volts as a total voltage, then this must be 9 volts. So VR is 9, V2 is 3, R is the thing we're looking for, and R2 is 240. So R is equal to 9 times 240 all over 3. So this means R must be 720 ohms. And this works out to be D. Question 14 says 3 resistors are connected as shown. The total resistance between X and Y is. So people might think this looks complicated, but all it is really is if I put a cell in, it probably looks something like this. And now you can see that this is in series. Well, the electrons need to go through this resistor, and these two are in parallel. So to get the total resistance, we do 1 over Rp for parallel equals 1 over R1 plus 1 over R2, which is just 1 over 12 plus 1 over 12, which is 2 over 12. And now we flip this since it's 1 over Rp. So Rp is equal to 2 over 12, 12 over 2, which is equal to 6 ohms. Now for RT, we do 12 plus 6, which is 18 ohms. And that works out to be D. Question 15 says a circuit is set up as shown. The reading on the ammeter is 0.5 amps, the resistance on the lamp is 8 ohms, and the power dissipated in the lamp is. So we have our current, which is 0.5 amps. We have our resistance, which is 8 ohms, and we need the power. So formula that relates all these three is P equals I squared R, which is 0.5 squared times 8. So P works out to be 2 watts. So the answer is A. Question 16 says a kettle, a television, and a microphone are connected to the main supply. The kettle has a power rating of 2.6 kilowatts, the television has a power rating of 170 watts, and the microwave has a power rating of 900 watts. Which row in the table shows the appropriate fuse rating for the kettle, the television, and the microwave? So, a lot of people learn it as if the power is less than 750 watts, then you use a 3 amp fuse, and if it's greater than 750 watts, then you use a 13 amp fuse. But the reason behind this is if you do P equals IV and you do I equals P over V, and you sub in any power, let's say 170, and since it's the main supply, we do 230, I works out to be 0.739 amps. And that's obviously less than 3 amps. Sorry, the other way. Less than 3 amps. And that's why we use a 3 amp fuse because it's less than 3 amps. So the normal operating current will be less than 3 amps. And if it rises above 3 amps, then this fuse will melt. So we can do that for all of these. But again, if you know this, then you'll save some time. So the answer works out to be B. Question 17 says a group of students sets up the experiment shown to determine a value for the specific heat capacity of water, and then you have this experiment. Now, the students make the following statements about how the experimental procedure could be improved. 1. Insulate the beaker to reduce heat loss to the surroundings, move the immersion heater further into the water, or use a stopwatch to measure the time for which the water is heated. Which of these statements are correct? So, we are investigating the specific heat capacity of water, and the formula that is used is EH equals Cm delta T. And now, if we rearrange for the C, the specific heat capacity, C is equal to EH all over M delta T. So here we need the amount of energy supplied to the water, the mass, and the change in temperature. So 1 would be correct because this gives us a more accurate reading of the energy supplied, as if heat is lost to surroundings, then more heat energy is required to heat the water. 2 is also correct because this also prevents heat energy from being dissipated up here, up here. So if we move that closer in, more energy will go to it and give a more accurate reading of our joule meter. And 3 is incorrect because there is no need for time or seconds in our specific heat capacity. So 1 and 2 are correct, and that gives us C. Question 18 says a hot substance is cooled. The graph shows how the temperature of the substance changes with time. So it doesn't give you the initial state, it just says it's a substance. And a student makes the following statements about the substance. 1. The boiling point of the substance is 120 degrees Celsius. 2. At a time of 40 minutes, the substance is a gas. 3. The melting point of the substance is 20 degrees Celsius. Which of these statements are correct? Okay, so a little trick here is when the line is horizontally straight, this is changing state. So over here and over here. And now you can see that it starts up here at a really high temperature of 160 degrees Celsius, and it changes temperature here. The diagonal lines signify the substance changing temperature. So changing temperature, changing state, changing temperature, changing state, changing temperature. So at this high temperature, it's obviously going to be a gas, changing from a gas to a liquid. So gas to liquid. Here is going to be liquid to solid. Now, statement 1 says the boiling point of the substance is 120 degrees Celsius. So you can see the line is changing state at 120 degrees Celsius, and that's when liquid to gas. And that means this is correct because water boils from a liquid state to gas state, steam. So this must be the boiling point. So 1 is correct. 2 says at a time of 40 minutes, the substance is a gas. Well, that's incorrect because we're changing here from a gas to a liquid. So in this state, we've just changed to a liquid at this point here. and the liquid is changing temperature. So at this point we are liquid, so this must be false. 3 says the melting point of the substance is 20 degrees Celsius, and using the same technique from before, you can see the line is horizontally straight at 20 degrees Celsius, so it must be changing state here, and that means the melting point is at 20 degrees Celsius. So the answer is C. Question 19 says a ballet dancer wears shoes that have a flat section on the front called a platform. When the ballet dancer stands on the tips of the shoes, the platform on each shoe is flat on the floor. The area of the platform on each shoe is 1.6 times 10 to the negative 3 meters squared. The weight of the ballet dancer is 520 newtons. The pressure exerted on the floor by the ballet dancer is. So here we have to use the formula P equals F over A, and force is the weight, which is 520 newtons. And be careful here, the area is the total area, and we have two shoes here, so two platforms, and the area on each shoe is 1.6 times 10 to the negative 3 meters squared. So we just do 1.6 times 10 to the negative 3 meters squared times 2. So P works out to be 1.63 times 10 to the 5 pascals, and that works out to be D. Question 20 says a tennis ball contains a fixed mass of air at a temperature of 20 degrees Celsius. The pressure of the air inside the ball is 1.9 times 10 to the 5 pascals. During a tennis match, the temperature of the air inside the ball rises to 35 degrees Celsius. The volume of the air remains constant. The pressure of the air inside the ball is now. So here, the things that are changing is the pressure and the temperature. So we use the formula P1 over T1 equals P2 over T2. And I'm going to assume that P2 is the one that I'm going to be working out. So P1 is 1.9 times 10 to the 5 pascals. T1 is 20 degrees Celsius. Now be careful, when you're doing these questions about gas laws, temperature should always be in Kelvin. So we do 273 plus 20 to convert to Kelvin. P2 is the thing we're working out, and T2 is 273 plus 35. So P2 rearranges to 1.9 times 10 to the 5 times 308, sorry for the bad handwriting, over 293. So P2 works out to be 1.99 times 10 to the 5 pascals, and that rounds to D, 2 times 10 to the 5 pascals. Question 21 says the diagram represents a wave. Which row in the table shows the wavelength and amplitude of the wave? So the trick to this question is to count the number of waves. So we have 1 wave, 2 wave, 3 wave. So 3 waves in 120 millimeters. So 120 millimeters divided by 3 is equal to 40 millimeters. So we can rule out A, D, and E. And then next, the amplitude is the distance from the 0 position, so this dotted line, all the way to the peak or the trough. So it could be this way or either this way. And you can see there's just half of this 0.2 meters, and that works out to be 0.1 meters, and that works out to be B. Question 22 says a teacher gives a group of students 2 clues to identify a particular band of the electromagnetic spectrum. Clue 1 diffracts around obstacles more than visible light. Clue 2 has a greater frequency than microwave radiation. The band of electromagnetic spectrum these clues refer to is. So the way I would do this question is I would memorize the order of the waves from either left to right or right to left. So I know it as just the initials, so G, X, U, V, I, M, R. And these represents the different electromagnetic radiation. And on this side of the spectrum, we have a high frequency and a low wavelength. And on this side is the inverse, so um, do the other way. Low frequency and a high wavelength. And let's use clue 1. Diffracts around obstacles more than visible light. So what it's saying is electromagnetic radiation that has a longer wavelength diffracts more. That's a fact you should know. So it should diffract more than visible light. So it's got a longer wavelength than visible light. So it should be closer to this side of the spectrum. So we can rule it down to these three over here. And clue 2 says has a greater frequency than microwave radiation. So microwave radiation is M over here, and we want the one closest to this side. So that works out to be this one, infrared radiation. So that works out to be B. Question 23 says a radioactive source has an average activity of 5.2 megabecquerels over a time of 1.2 hours. The number of nuclear disintegration that occur in the source in this time is. So we use the formula A equals N over T, or N is the number of disintegrations, so that's 5.2 times 10 to the 6 disintegrations. And then this is the time, and time is always in seconds for this formula. So we do 1.2 hours times 60 minutes times 60 seconds. And that works out to be 1.2 times 10 to the 3 becquerels. And that gives answer A. Question 24 says a sample of tissue is exposed to a source of alpha particles. The equivalent dose received from this source during a time of 5 minutes is 480 microsieverts. The equivalent dose rate is. So notice how they give all the options in microsieverts. So let's not convert this to a scientific notation. So we use the formula H dot is equal to H over T, where H is the equivalent dose received, and that is 480. Again, we're not converting since they give the options in microsieverts already. And T is seconds, so we have to convert this to seconds, so 5 times 60. And that gives us 1.6 microsievert hour, seconds, sorry. So this gives us answer A. Question 25 says, energy is released when two small nuclei combine during a nuclear reaction to form a larger nucleus. This is a description of. So you should know when two small nuclei combine or fuse together, it's called nuclear fusion. So the answer here is B. That's going to be all for this video. Comment down below what you got if you're comfortable, obviously. Make sure you follow my TikTok and visit my website, which are all linked in the description. If you have any questions, just let me know in the comments. And other than that, I'll see you later.